Hey, I kind of got caught up on the last video. I left you hanging. So I had a student come in that I had to stop the video. So going back to this problem from earlier, the interquartile range is the upper quartile minus the lower quartile. So in this case, it would be 40. Now, if you click on, this is slide 6, but if you click on slide 7 explains it, 8, 9, 10, there's that's where we got the 40. So it explains it all out in words if you need it. Okay, so then we talk about outliers. Now, I'm not going to give you any heavy-duty outlier questions. I think of outliers personally as things that are way outside the norm. So if I look at this particular little set right here, 91, 92, 93, 94, they're all really close together. There's nothing that really stands out. But if you look at that next group, I wrote it all on one line where you can see it better. You have the 90s in there, but you also have a 21 and a 150. And so those really stand out compared to the rest of the data. So that's what I call outliers. And that's what I'll ask you on your quiz for this week. Technically, though, outliers have an actual value. So an outlier is anything that's more than 1.5 times the interquartile range. Okay? So they give you an example here with metals. So it tells you, it finds all the data for you, so that's very nice. But your interquartile range is going to be 49, because it's quartile 3, which is your upper quartile, minus 15.5. Okay, so if we calculated that, 49 minus 15.5, we get 33.5. Now, an outlier is 1.5 times that value. So I'll multiply times 1.5, and I get 50.25. So the actual definition of outlier would be if I took 49, this value right here, the upper quartile, and I added 50.25 to it, I would get 99.25. So anything above 99.25 would be an outlier. Okay, it also works down here at this one. This is my lower one, 15.5. So if I subtracted 50.25 from it, oh, well, I can't, because I can't have a negative number of metals, right? So there's no lower outlier. So even though it looks like 7 is really low compared to the other ones, it's really in this range. It's not as low as it looks. So the actual definition of outlier is something that's more than 1.5 times the interquartile range above or below those upper and lower quartiles. I'm not going to be that tricky, but that's how technically you would work it. Okay, and this is how they answer it there. The measure of the spread is needed when data are summarized with a single number, such as a mean or median. So we talked about the interquartile range, we talked about the range, but the most sophisticated one is the standard deviation. Okay? So it gives you the directions here on how to find the standard deviation. Here is the formula. This formula will be provided for you on your exam. Okay, now here they're showing you that this group and this group have the same mean, but they're so dramatically different in the way that the groups look. So these next couple of slides are going to show you about that one. I'm not real interested in comparing those two. I'd prefer to give you real examples. They also talk about normal curves. Okay? So you might have heard things before that this data is shaped based off of a normal curve shape, and this is the normal curve shape. This will also be provided for you on your final exam. So this is your mean right here, not your median, but your mean, and you're calculating standard deviations. So from here to here is one standard deviation in both directions. And from here to here is 2 standard deviations in both directions. And from here to here is 3. Okay, and so we're going to work some problems with that one. I'm going to erase it because we're going to come back to it. And we need to remember that this is that page. Very good. Now, going back to it, 68% of the data would fall between here and here. So you got 34 and 34. So that's 68% would fall in this range if your data is based upon a normal curve. Another thing that I'll show you is the mean divides the data in half. So that means there's 50% above and 50% below. Okay, so that's another thing to notice. If I just looked at this part, that's 34. If I look from here to here, that's 34 plus 13.5, which would be 47.5. And if I look from here to here, it would be 47.5 plus 2.35, which would be 49.85, which would leave you with 0.15 on the end. Now, there's a whole host of questions I can ask you for it, so we're going to do that in just a little bit. Okay, here's some words that you can read through. Okay, and I think that's your first example. Let me flip through and see where it goes from there. Okay, great. Okay, normal curves. So I'm going to skip this normal curve one now and do all the normal curves in video 3. So let me get past this one. Percentiles. Okay, so we're going to do percentiles and then we'll come back and get the normal curve. A percentile shows a person's score relative to other scores. They also talk about deciles, but I've never used deciles, and I do a lot of math, right? The main way that I've heard percentiles is when you're talking about rank in a class. Like if I went to a big school, we'll like take South Panola, for example. If you went in a big school and you were in the upper 10th, that'd be, you'd be ranked in the top 10. That's the type of thing you're looking in percentiles. You also might see percentiles if you had a child and the child was taken to the pediatrician and they said your baby's height is in the lower 10%. So they also talk about it when comparing. That's when I've heard it compared to baby heights. So if I talk about Aussie here, she was ranked 25th in her class of 250. What is his percentile rank? So if he was 25th in his class, that means that 250 minus 25, so 225 people are below him. Okay, so you would take 225 and put it over 250, and so that would be 90%. So Aussie was in the 90th percentile. So the way that you find it is you find how many are below over the total number. Now you also have to change it to a percentage. So if you divided 225 by 250, you're going to get 0.9. So remember, to change that to a percent, you move it over 2 places. So it's 90, it would be 90%, which would be the 90th percentile. Because remember, percents are part of 100. So percentile would be part of 100. Okay, in this particular case, Kat had a percentile rank of 60. What is her class standing? Okay, so 60 would be 60%. So there were 50 people in the class. So if you took 60%, remember to change it to a decimal, we're going to move it over. 0.60 times 50, if you multiply that out, you would get 30. So Kat had this tricky, almost got me. So Kat had 30 people below her. Okay, so if she had 30 people below her, that means she was the 20th in her class because there were 30 below her. So don't fall for that little trick like I almost did. Okay, we'll go ahead and knock these 2 easy ones out, and then we'll save the bad stuff for video 3. If the youngest teacher on staff is 26 and the range is 41 years, how old is the oldest teacher? Okay, so remember the range is high minus low. So in this case, it would be old old minus young. So I don't know how old the old one was, but the young one is 26, and their range is 41. Okay, so the difference between them is 41. So if we solve this out, the old one would have to be 67. Old's not the appropriate term. Let's say experienced. The experienced one is 67. Okay, so recently I was looking for some Adidas, right? And so I was looking for some shoes and comparing prices. And I made this one. They weren't all this type of price, but they were in this ballpark range. The lowest price was 45 that I found, and the highest price was 125. So as I was looking at the range of the prices, it would be 125 minus 45, which would be 80. That was the range of prices that I found.